So good day everyone. We have here a problem about second order reaction that is not reversible. The problem states that a quantity of ethyl ethanoate is reacted with an excess of sodium hydroxide at 25 degrees Celsius. The amount of sodium hydroxide used in the reaction was determined from the following method. 1. 100 ml of the reaction mixture required 68.2 ml of 0.05 mole per liter hydrochloric acid for neutralization at the beginning of the reaction. After 30 minutes, 100 ml of the mixture similarly required 49.7 ml of the acid, and when the reaction was complete, 100 ml of the mixture required 15.6 ml of the acid. The reaction is not reversible, and we are asked to find the specific rate with the reaction formula of A plus B equals to product. So, in order to solve this problem, we have to analyze what is asked and what is given. So first, we will write the given in the problem. So we have our reaction, which is A plus B equals to product. Then we know that our A is the ethyl ethanoate, which has the chemical formula of C4H8O2, and our B is the NaOH, sodium hydroxide, so plus NaOH equals to product. So next, we will analyze what are the given parameters in our problem. In our problem, it is stated that at the very beginning of the reaction, 68.2 ml of 0.05 mole per liter HAl is used for neutralization. So, we are going to tally this at a table. Have T where our time is per minute, T at 0, and our CB, because HCl is used to neutralization, which will give an equivalent of NaOH, which is RCB. So we have 68.2 ml of 0.05 mole per liter acid, which will give 3.41 times 10 to the negative 5 mole per ml CB. Next, stated that at T 30 minutes, we have 49.7 ml acid, which will be multiplied 0.05 moles per liter is equals to 0.05 2.485 times 10 to the 5 mole per ml. Next, we have when the reaction is complete, so we have T complete, we will have 15.6 ml of 0.05 moles per liter, which is 7.8 times 10 to the negative 6 mole per ml. Now, these are the given data in the problem. We also have a temperature of 25 degrees Celsius. So in order to solve this kind of reaction, which is a second order reaction that is not reversible, we have to find CaO, and the first one will be CBO. This will be our CBO. So in order to find this, we are having properties of, this will be given. So we are going to have properties of our A, which is, in order to solve, we have to have its density at 25 degrees Celsius, which is 0.902 gram per ml. We will also have the molecular weight. This is for C4H8, which is our ethyl ethanoate. So we have the molecular weight of 88.11 gram per mole. So in order to find our Ca, we will use this data. So time per minute at t equals to 0, our Ca will be 100 minus 68.2 times 0.902 gram per ml all over 88.11 gram per mole. We will have an answer of 3.255 times 10 to the negative 3 mole per ml. So at time 30 minutes, we'll have 100 minus 49.7 times 0.902 gram per ml all over 88.11 gram per ml. We'll have a product of 5.149 times 10 to the negative 3 mole per ml. Also at time complete, have 100 minus 15.6 15 times 0.902 gram per ml over 88.11 gram per ml is equals to 0.998 mole per ml. So, this is our data. Next, we will solve or we will derive the formula which will be used in order to solve this problem, in order to find the rate of reaction. First, we have a reaction which is negative dCA over dt is equals to KCA/CB, which is the second order non-reversible reaction. Then, we will transpose it to conversion. This will be negative CaO dx over dt equals to KCaO CaO minus X all over CbO minus X XA minus XB. So, we'll have a negative dx all over CaO minus XA times CbO minus XB is equals to K dt. In order to solve this, we will be using partial fraction. So, we have 1 over CaO minus XA is to CbO minus XB is equals to A over CaO minus XA plus B over CbO minus XB. We have to simplify this. We have A times CbO XB plus B CaO XA. So, we have if CbO is equals to or rather we have CaO is equals to XB, we will have a 1 is equals to A CbO minus CaO plus B equals to, and we have also CbO equals to XA. So CbO minus CaO. So we'll have A equals to B equals to 1 all over CbO minus CaO. We will substitute this into our reaction. Come here. So we will have 1 all over CBO minus CAO times 1 over CAO is XA plus 1 all over CBO XB. We have dx, so dx here equals to K dt. So you can integrate this now. Integration of this one will have 1 over CBO minus CAO equals to ln you have that negative here, so ln CBO plus XB all over CAO is XA integrated from 0 to x is equals to KT. We have that KT. So, simplifying XB and XA, we'll have 1 over CBO minus CAO ln CBO minus, we have XB is equals to CBO minus CA. So we have CBO minus CBO plus CA, which is CB, I mean. We also have CAO minus CAO plus CA equals to KT. So this can be cancelled out. This also can be cancelled out. So this whole equation here is over CBO. This whole equation here is over CAO. So integrating or simplifying it, we'll have CAO ln CB CAO all over CBO CA is equals to KT. So this will be the formula that we are going to use in solving the rate of reaction. Next, we're gonna solve the rate of reaction. So we have the formula 1 over CBO minus CAO ln CB CAO all over CBO CA equals to KT. And we have the data a while ago, which is at T0 and at T30. We have the CB and the CBO. At T0 and at T30, we have CA and the CAO. So we're going to use it now. So, say at T equals to 30 minutes, we have 1 over 3.41 times 10 to the 5th minus 3.255 times 10 to the negative 3 equals to ln, we have the CB, which is 49.7. I don't know, we have the 2.485 times 10 to the negative 5 times CAO, which is 3.255 times 10 to the negative 3 all over 3.41 times 10 to the negative 5 times 5.149 times 10 to the negative 3